Hello students, today we will discuss about magnetic effect of electric current, chapter 2nd of physics in class 10th. In the previous chapter, that is electricity, we have learned that whenever the current is passing through a conductor, then it produces heating effect. But beside this, current has also one effect. Whenever the current flows across a conductor, it produces magnetic field also. I am talking about electric current. We generally say that whenever the charges are in motion, then it constitutes electric current. It means whenever the charges are in motion, they produce magnetic field around them. In 1820, a scientist named as Hans Oersted, he accidentally discovered that if we pass the current through a wire and if we place magnetic needle near to it, then it got deflected. Why it is? Because when the current is passing through the conductor, it produces magnetic field around it, and due to that magnetic field, the needle got deflected. And with the help of Oersted experiment, we came to know about that electricity and magnetism both are interlinked. It means with the help of electricity, we can generate magnetic field. Understood? Okay. For the direction of deflection of this magnetic needle, we have a rule named as snow rule. It means south, north of west. What does it mean? If we place the current carrying conductor along S to N direction and the current is passing from S to N, then the needle got deflected along west direction. That is south to north current. The needle will deflect along west direction. Ye clear hai? Okay. It means what is the meaning of magnetic field? For example, we have this current carrying conductor and it produces its effect in the surrounding. That effect is known as magnetic field. Ye clear hai? Okay, now the question comes how to study this magnetic field, how to visualize this magnetic field. For the visualization of magnetic field, we have a concept named as magnetic field of lines. With the help of magnetic field of lines, we can visualize the magnetic field, its direction at any point in the space. Okay, this concept was introduced by Michael Faraday to visualize the magnetic field in the space. Now we will discuss about that how to draw this magnetic field of lines, what does they represent, and what are the properties of these magnetic field of lines. Okay, now the question comes how to draw the magnetic field of lines. Okay, for this we have to take an artificial magnet named as bar magnet, and we have to sprinkle some iron fillings around the bar magnet. Okay, look at this figure. देखेंगे, if you have a bar magnet is an artificial magnet in that, and it has two poles N and S, north and south. Clear hai? Okay, if we sprinkle some iron fillings around it, then the iron fillings take a regular pattern around it. Clear hai? Achha, why iron fillings take this type of pattern? Because bar magnet produces its effect, that is magnetic field around it. Due to that magnetic field, these iron sprinkles arrange themselves. But keep in mind that more crowdness of iron fillings are at or near the poles, that is north and south. It means maximum effect of magnetic field is at the poles. Clear hai? Okay, now if we draw the lines with the help of iron fillings like this. For example, this one. This represents the imaginary curve named as magnetic field of lines. Clear hai? Second method we have that with the help of compass needle. With the help of compass needle is also an artificial magnet and has north and south pole. And it is used for find the directions or in the navigation, we can say. Clear hai? Okay, if we place bar magnet and some compass needle around it, clear, then we know very well that like poles repel each other but unlike attract each other. If we place bar magnet, the south pole of magnetic needle comes near to the north pole of bar magnet, and north pole of magnetic needle goes away from the north pole of bar magnet, and the magnetic needles take this type of pattern. If we draw a line like this, then this represent magnetic field of line. इसका मीनिंग क्या होता है? If we place magnetic needle or iron fillings at these points, then they will experience a force due to this bar magnet, because at these points the effect of bar magnet is there. Clear है? Now we discuss what do you mean by magnetic field of lines. These are the imaginary curve tangent to which gives the direction of magnetic field at that point. Meaning क्या है? For example, we have this curve, magnetic field of lines around and bar magnet. If we take at point A, and if we want to take the direction of magnetic field at this point, what we have to do? We have to draw a tangent. This tangent gives the direction of magnetic field at this point. तो इसका मीनिंग क्या हुआ? जो भी मैग्नेटिक फील्ड होती है आपको एक विजुअलाइजेशन देती है कि स्पेस के किस पॉइंट पर मैग्नेटिक फील्ड है और उस पॉइंट पर मैग्नेटिक फील्ड की डायरेक्शन क्या है. क्लियर? ओके. नाउ वी विल डिस्कस प्रॉपर्टीज ऑफ मैग्नेटिक फील्ड ऑफ लाइंस. Before this, we will take a look at field lines due to bar magnet. देखेंगे, we have a bar magnet like this. If we draw magnetic field of lines with the help of iron fillings or with the help of magnetic compass needle, these are like this. Clear? Okay. Look carefully at this diagram. The magnetic field lines emerge from pole N and at pole S outside the magnet. ये clear है? And inside the magnet, the direction of magnetic field of lines is from S to N. Second, okay, if we look at the crowdness, देखेंगे, the crowdness is more, the crowdness is less, and crowdness is decreasing as we go from the bar magnet. What does it mean? We know that whenever we are very close to the magnet, its effect is maximum. As we go away from the magnet, the effect of magnet decreases, and as we go away from the bar magnet, the spacing between the lines decreases. Clear है? Okay. Now we will come at properties of magnetic field of lines. देखेंगे. First, magnetic field of lines emerge from north pole and at south pole outside the magnet, and inside the magnet they travel south to north pole. It means they form the closed loop. Okay, second, keep in mind, no two magnetic field of lines can intersect each other. Why? Because if you take point P and two magnetic field of lines are there at point P, they are intersecting. Then with the help of tangents, we can draw two directions. But if they do so, then there will be two direction of magnetic field of lines at point P, which is not possible because magnetic field is unique in the space at every point. What does it mean? If you place magnetic needle towards at the point P, due to this line, the needle will go like this, and due to this magnetic field of line, the needle should go like this, but needle will go in the one direction. So it is not possible that at any point in the space, two magnetic field of lines intersect. Clear? Okay, third property, the main. The relative strength of magnetic field is shown by the degree of closeness of magnetic field of lines. For example, we have region A and region B. Here the density of lines is maximum, big means more crowdness of magnetic field lines are there in region A in comparison to region B. It means magnetic field in the region A is high than magnetic field in region B. Or we can say that magnetic field is high where the magnetic field of lines are closer. ये clear है? Okay, if you look again at the field lines pattern due to bar magnet. Okay, if you look at the region 1 and region 2, here the spacing is very less, here the spacing is more. We can say that crowdness is there. Your spacing between the lines is very less, and here is more. It means the magnetic field is maximum or greater at this region in comparison to region B. Clear? Okay, keep in mind, more crowdness of lines are at the pole or near the poles. It means if you look at the bar magnet, clear, maximum magnetic field you will find near the poles. And as we go from the pole to the center, it decreases. Clear, student? Okay. Students, in second video, we will see magnetic field due to current carrying straight wire, circular wire or solenoid. Okay, student.